Alright, let's start with the basics on this thing, the basic layout and all the parts. This end here attaches to your focuser, and this one is a 1 1/4. It's very thick walled and it should hold pretty much a lot of weight. You can swap it out by taking these 4 nuts off, and the front will just pull off. You can put a 2-inch focuser on it as well. So I'll include this in there. You can see the slit down in there, and the slit is adjustable by this housing assembly. By turning this adjustment here, you can adjust the width of the slit. Only one of the slits adjusts, and what happens is you can back it out all the way and it will stop. That's all the way open. That'll allow you to see the whole half of the field of view. This stop nut on this side will hit right about the point the two jaws come together. So by gauging the opening here, you can tell about how far your slit's open. Okay. This is the main body that's going to hold the eyepiece. The eyepiece will go inside here, and then we'll project the image of the slit onto the camera. The camera will mount in here. It's a standard 1 1/4 focuser, and it's got 2 glass-filled nylon lock knobs. You'll focus it by going like this with the camera. It should be about halfway, and then you can twist it a little bit back and forth to get the fine adjust. The grating will go on the camera's nose piece. It needs to be about at least 1 inch away from the chip to get a good projection. One other feature this has that no other spectrograph has is this adjustment here. This is your back and forth adjustment, and will allow you to center the spectrum rather than the slit. The slit is on axis all the way through, so if you put the camera on here, you'll get an image of the slit and the spectrum will be off to one side. By adjusting this offset here, you can center the spectrum, tighten these bolts down, and you'll have a perfectly focused spectrum that's exactly in the center, whereas the sharpness will be retained because everything will still be on axis. This is the screw here to take the eyepiece inside out, and once it's set, you don't touch it. You just leave the eyepiece in here all the time. It's designed specifically for a 32mm eyepiece. Alright, that's the basics. Let's get into how to put this thing together. Alright, the first step in using this is we have to install the 32 Plössl eyepiece, which is going to go in this housing here. To do that, you're going to need to remove this screw so you can get at this bolt, back off both of these bolts. You don't have to take this one completely out, and then you can pull the slit off completely or turn it to the side. So let me demonstrate that, and we'll install the eyepiece. Okay, it's loose. That's about as far as you really need to go. We're going to insert the eyepiece down inside here, and then what we're going to do is we're going to take a wrench and we're going to tighten this down. We're going to use a 3/32 wrench, and we're going to tighten this down until the eyepiece is, make sure the eyepiece is fully seated. We're going to tighten this thing down, snug it up, and we're done. Okay, now the eyepiece is ready to project the image. Now what we're going to do is we're going to put the bolt back in. You can do that easily by going in sideways like this and then rotating it to get it in the hole. So let's put it back in. Alright, first thing we're going to do is tell you how to install the grating in the camera. Believe it or not, there's a right way and a wrong way. So you got to have a minimum of projection distance of at least 1 inch. 1 1/4 is better. Okay, so in my case it threads on a certain distance and kind of seizes up. Now what you want to do is you're going to take a flashlight and you're going to shine it down into the camera like this. Now when you do that, let's see if I can get where you can see this. When you do that, there's going to be an image. There you go. There's going to be an image of the chip, like a spectrum next to the chip, and it's going to be at some angle. What you need to do is, while the flashlight is shining in there, you need to rotate this until it goes straight horizontal this way, so it lines up with the edges of the chip. This is the only way you can do this, and it's pretty easy to do. Once you got this lined up, this may be loose, okay, to be able to do that, but you know, it's not going to rotate once you get it done. So basically, that's how you get the alignment done on the grating, the star analyzer. Okay, once it's aligned, you're going to insert the camera such a way as the slit's going this way. You want the dispersion to go right and left. Ideally, you want it to be you want the image to show the slit on the left and the spectrum on the right on your computer screen. You can line up along these edges here to make sure your camera is roughly square. Just lock one of them down about halfway, and the next step we're going to take a look on the computer screen and get everything lined up. Okay, now it's tightened down. We're going to rotate the camera in the focuser and try to get everything squared up. So what you want to do at this point is adjust it so that the spectrum is not overexposed. Let's turn down the exposure on the spectrum. Okay, and then we can close the slit down at this point. So it's relatively small. Okay, now you can see some spectral lines. Basically, you want to focus on the spectrum. Okay, the spectrum itself is going to be a slightly different focus than the image of the slit. So go ahead and focus on the spectrum at this point. Turn your camera so that everything's square, and then you're pretty much tighten everything down and you're ready to go. Okay, this is what you're going to see. I closed the slit down a little bit. This is my spectroscope, by the way, because they've got the eyepiece installed in it. Your slit came out a lot more parallel than mine. Basically, you can see the spectral lines very clearly. The slit is off to one side, and so when we do a scan, everything will be lined up so that the slit's on the left when you bring it into RSpec. Now, RSpec is just going to take a slice, a very narrow slice of your spectrum. And so you're going to pick the best spot that appears to be the sharpest, the least defects, and that's what actually is going to generate the spectrum. When you're ready to actually do the spectrum, you're going to go on to take a 100-frame movie. A 100-frame movie will allow you to average out the noise. Then you combine that into a BMP file, which can be imported into the RSpec program. Okay. In the RSpec program, you can see what I've done is you can move the slit up and down and pick the best part of the spectrum. This is the fluorescent lamp spectrum, and as you can see, it looks pretty darn good. It picks it up pretty sharp. Basically, that's how you get the spectrums, and to calibrate it, you're going to have to determine how many angstroms per pixel. Mine's 9.3 angstroms per pixel, but you're going to have to calibrate this thing either by aiming it at some kind of like a star Sirius or something, or if you know the spectral lines in a neon lamp or something, you can set it. Once you know the dispersion and the DC wavelength, it will calibrate. So there you are. That's how you do this, and good luck and happy sky shooting.